Hi, everyone. My name's DiBona. I look after some space stuff here at Google. Well, I mean, sort of, kind of a relationship guy with Ames. And we're pleased and honored today to have Dr. Worden with us from Ames. Are you, what's the title there, Grand Poobah? Emperor Liege? What's the title they have for you at Ames?
Unindicted co-conspirator.
Unindicted co-conspirator. On a bad day in Washington, yeah. So Pete leads NASA Ames Center, you know, our next door neighbor and our landlord there for our space there. And thank you so much for coming over and or having us there, right. You know, but coming over and visiting us today. Pete has a very long history, both with space and working for our country and moving science forward, which is how I got to meet him in the first place. Your career goes back 20 years in the Air Force?
29.
29 years in the Air Force. And then
29 years, 3 weeks, 2 days.
Really? You counted off?
That's right.
And when you were in the Air Force, you worked through the Air Force Space Command.
Part of my assignment.
So there was always, and I've always been interested in this about you, but also about the relationship between NASA and the Air Force, because there was a lot of tension at the time around the shuttle program, around other things, wasn't there?
Well, I mean, NASA.
I know this is weird because
NASA has a long history. I mean, it's the Air Force even longer history. The in the 1950s, many in the Air Force began to understand space was pretty important, even in the early 50s, and the ICBM program was you know, probably don't like me calling it, but they were space weapons. And so they developed ICBMs, and about the same time the country got very interested in space programs in general. And in 1957, when the Soviets surprised us with Sputnik, there was a lot of turmoil about what we were going to do, and there were really two options. One was to have the military run the space program and expand greatly to do satellites and so forth. And then the other one was to set up a civilian agency. And there was a lot of turmoil back and forth, but President Eisenhower decided that it was, he wanted to have the face to the world being a civil space program. And it turns out actually worked very closely with NASA and the National Security Space Program, although it's important to understand there's really two National Security Space Programs. There's the National Security Space Program that the Air Force leads that has things like the Global Positioning System and communication satellites, and then there's the other program, which I couldn't even talk about until about 10 years ago, but it's the National Reconnaissance Office, one of those no such agency organizations that do spy satellites. And
well, I guess the story about how the world found out about the NRO was when they were paying too much taxes on their Fairfax buildings. And people are like, well, who is this actually paying all these taxes? Is this the government paying taxes just so it can remain secret? And then they got outed because of this.
Right. Yeah. Well, there's a lot of different issues, but we've worked very closely together and sometimes competed. I think probably the really interesting thing about the history is that the Apollo program was really a surrogate national security effort that the Soviets and the United States sort of mutually decided to compete in space, and it was a surrogate for a hot war. It was part of the Cold War, and the issue was that whoever won that kind of basically scared the other one to say that, you know, look, don't challenge us. Look what we can do. And it was a closely run thing. I mean, it was, but it turned out most of the people that started NASA were military. And we still work very closely with the military, although there have been times. I mean, probably the most interesting one was the space shuttle. When it was developed, the military decided it didn't want anything to do with it. And it turned out one of my predecessors as the director of NASA Ames was Hans Mark. And he was the Secretary of the Air Force. And he said, by golly, we're going to rely on the space shuttle. And so started to convert the whole military space program over to use the space shuttle, and they picked military astronauts, and it was there's a huge launch complex at Vandenberg Air Force Base that was for the blue shuttles, and then
painted them blue.
Well, actually, we were going to do that.
But it was,
you know,
too heavy.
I
blue
mean,
the heaviest
you know,
color.
white is kind of a NASA color,
Yeah.
and you know, blue is the light blue,
Yeah.
sky blue. But it turned out the Challenger disaster occurred, and the Air Force said, okay, that did it. We want to use expendable boosters, which probably was a good idea, not to put everything in one. But it's a long history. My boss, the NASA administrator, Charlie Worden, is a Marine general. You know, not all of us can be Air Force people, but it's,
What rank did you achieve in the Air Force?
it was a brigadier general.
You were a brigadier general.
That's
Yeah. So
sometimes called a baby general. It's
a
one
baby
star.
general? Just one star. Oh, just one star.
That's
wow. Come on.
But I found out that nobody knows the difference between a brigadier general and a lieutenant general and a major general and a full general, unless you're in the military.
I have no clue what you're. Yeah. How many is that a star for every?
Yeah, you know, full generals have 4 stars.
And isn't the president like 6 stars? Is that officially what he is?
No, he's just the boss.
He's just the boss. Well, that's good. No, it's really interesting. I just always found the relationship to be an interesting one to watch. We have questions from the audience, but I have many little questions. So I'm going to hit a couple of the things. You and I have been talking recently about propulsion methods. And you had mentioned during lunch today that you were looking into a solar sailor mission. Do you want to say anything about that?
Sure. I think probably maybe take just a minute to say
it's a
that.
little far out.
No. It's not very far out. It's pretty cool. But I think there's. I like to think that NASA does 3 things to kind of give you an introduction. The first one, because I'm a scientist, is science, and we basically are trying to find out the secrets of the universe. And there's 2 fundamental ones. One is, you know, how did the universe begin and what's its structure? And the other one is, how did life begin and where else is it, and what's its future? And much of what we do is around those topics. The second thing NASA does is where a lot of the controversy is, a human space program. But I think we're on the verge of humanity will expand in the solar system this century, and NASA and its partners around the world are leading the way. The third one we probably don't talk enough about, and it may be the most important, is to make life better here on Earth. And the first day in NASA is aeronautics, and we're going to have to transition sometime to green aviation. One of the big initiatives NASA has is green aviation. At Ames, we're doing the next generation air traffic control system, so it's you know, so it affects everybody. And the other one is really studying the Earth and understanding how climate change affects us. Most of the data that we base our climate change models on is based on NASA data. But to get to the solar sail issue is that it's really kind of a cool concept. You know, I grew up on Star Trek and Star Wars. As a military guy, more Star Wars, I guess. But you know, I sort of thought we ought to be building starships. And in fact, a few years ago, you know, we started a program between DARPA and NASA, but it caused enough controversy, so DARPA and NASA dropped it. But now the private sector is picking it up, which is really cool. But the technology is there in the next 10, 20 years that we can get access to near interstellar space. And one of the cool ways to do it was actually thought of it.
You mean post the heliopause?
Yeah, outside, so you're really in interstellar space. Is and I have to confess, this wasn't Ames work. It was actually done at Caltech and JPL. Was just to mention our competitor that we love dearly, for the record. Just as you love, you know, Microsoft and, you know, Facebook.
Love's an interesting word.
Yes, certainly is. But it turns out if you're going to get to near interstellar space, you have to give very high speeds. The highest speed object we have are the Voyagers, which are something like 18 kilometers a second. And the Voyager is like 120 astronomical units, which is the distance between the Earth and the Sun. So it's just now getting close to the boundary between the what's called the heliosphere, which is where the Sun dominates in interstellar space. And it took 30 years or so.
It cracks me up how people treat that.
Right.
Because we've had like 10, 12 different headlines.
Yeah,
we're
we're not. We're still kind of close. But we really want to get a couple hundred kilometers a second. And that's possible, but hard to do. But there was a concept about 20 years ago that said, let's use a solar sail, just using the pressure from photons. But the problem then is that the satellites were kind of big and heavy, so it was kind of hard to do it. But with these development of these little mini nano satellites, whatever you want to call them, that weigh, grams, hundreds of grams maybe, a solar sail can actually get you at high speeds if you go close to the sun. So, like a tenth of the, 10 million kilometers from the sun, for example. And it's, it's a little toasty, but machines can handle that. And if you do a couple passes by that, and you might be able to get a couple hundred kilometers a second. So we're doing a little bit of a study on how we could do that, and we think it could be fairly cheap. And there's a couple interesting places that you'd like to get to. One of them is called the gravitational lens point. I mean, the sun actually can act as a lens, so the gravity bends the light around it. And that's 600-800 astronomical units out. So if you could kind of align things right, you could maybe image planets around a nearby star, or image the core of the galaxy. And so it's a really cool concept, and I think it may be the next step in what we can do. So we're kind of looking at, how do you get these really high speeds? But it's not too soon to start thinking about true, near interstellar missions with, we don't have to have wormholes or other exotic physics. This is, not that those aren't cool, but.
Yeah, but not something we're going to see in the next 15 years.
Well, I don't know. There's a guy at Johnson Space Center that's actually, working on warp drives and so on.
Yeah, but isn't that one of those things that starts with, assuming you have a wormhole handy, then you could, that kind of thing, or you have a negative mass.
Well, I guess this is, a lot of people, NASA sometimes gets criticism when we work on, far out stuff, but that's our job.
Well, I mean, it is.
And it's reasonable for an agency like NASA to have a few people that are really looking at exotic stuff. And, most of this stuff is rubbish. But if somebody doesn't work on it, you never know. There's a guy by the name of Nikola Tesla that did a lot of rubbish, but a few other kind of interesting things like alternating current and other ideas everybody thought was bad.
Yeah.
And so I tend to refer to it as fruitcake science, but it's fruitcakes can be delicious.
Yeah, they can be, especially if you put enough bourbon.
That's right, you add some.
Or cognac. I don't know. It fruitcake. So near interstellar space is interesting, but what about going to, say, the closest other solar systems? I mean, if you had to game this, how would you get there in the next 30 years?
Well, speed is kind of a neat.
Right?
It's all about speed, and
then deceleration.
Yeah. Well, initially you just fly by.
Yeah.
But it's I think by the end of the century we'll be looking at things even on our present course. One of the things I'm kind of intrigued with, and this is since I'm here at Google, that you guys got a lot of money, you say, that if you have some extra, we'd be happy to help. But
we just bought one computer,
you let the attorneys note that I wasn't asking for any money. But one of the ideas we've got about speed is, supposing we did a race, a space race that you set a racetrack, say, a tenth of an astronomical unit in from the sun and a tenth of an astronomical unit out, and you had a cup, and that let the private sector compete. Whoever did that the fastest, every 3 or 4 years gets this cup. People spend hundreds of millions on the America's Cup, and it's. I think these kind of things are going to be a big deal, and all kidding aside, the private sector is increasingly important for our space effort. Private sector space endeavors, whether it's to make money mining asteroids or whether it's to do cool things like, get to interstellar space or just leave a legacy, is, I think, the next step. And a speed race is kind of a neat idea that so okay, the first winner, goes 30 kilometers a second, and you find after a while people are motivated to say, I want to get up to couple thousand kilometers a second. That starts to give you the ability to really get to think about nearby stars in decades. Still a ways to go, but at some point, the nearby stars are interesting target. Probably our first job as NASA is to figure out what's there. Mm-hmm. And the next big thing that NASA is going to do in science is to see if we can image planets like the Earth around nearby stars. One of NASA's missions, which Ames is lead for, is Kepler. And we're finding that essentially every planet or every star in the galaxy has planets. Probably 10-20% of them have planets that are in the habitable zone. A lot of those might be Earth-size. So that means a lot of these nearby stars are likely to have planets that at least what we know would be in the habitable zone about the size of the Earth. Mm-hmm. So our next big step is how do we image those? And the technology...
And terraform them. No.
Yes. Well, actually, I'll tell you, there is a way that, and I have to, this isn't my idea. It's you might have heard of Craig Venter. Sure. He came up with this a few years ago. It said, if you actually wanted to send something or go to those places, it wouldn't be Captain Kirk and the Enterprise, this sort of, 10,000-ton ship. He said you might be able to send a little box, mm-hmm. and
kudzu in the box.
Well, it's better than that. You actually beam it genetic information. It mm-hmm. then prints out the correct and uses the raw materials to start life there. You could print out humans or whatever you wanted. I suspect that may be the way we'll spread to the nearby stars. Of course, there might already be life there that might have a different point of view, but the little box lands, and they say, that's. If you see a little box out in the backyard, be suspicious.
Go ahead and step on it.
Yes.
Yeah. Along those lines, we've had, I think, we meaning the world through NASA's efforts, we've had remarkable success with the robotic missions. And I understand that a lot of that's come out of Ames. How much would you say that? I don't know. I don't want to exaggerate.
Well, I think it's important to most of our science is our robotic missions, mm-hmm. and Ames certainly has played a big role in that, particularly recently. But there's a lot of other parts of NASA. I mean, obviously I think the biggest centers for robotic missions are JPL and Goddard Space Flight Center. We've sort of focused on Ames and small things, cheap things, which is good in this fiscal environment.
Well, you have a lot of missions this year. I seem to remember you showed me a poster, and it's like 32, I want to say?
Yeah, there's something like 20 to 30 satellites in the next year that we're launching. Most of them are little tiny ones. But let me talk about robotics the thing that Ames really works on is autonomy. Mm-hmm. I don't want to use the word artificial intelligence because that sort of raises scary things.
It's a loaded term.
But autonomy is something, so a good bit of the autonomous work, how do we program something to be autonomous, is based on Ames work. So, it may say JPL on the outside, but it's got some Ames on the inside. Mm-hmm. And it's, they might not admit that, but it's, it does.
Southern California.
But it's this is a really exciting area, and you mentioned the work we're doing with Google on the Quantum Artificial Intelligence Lab. Now, I didn't pick the AI part, but we are convinced that perhaps the next step to autonomy is a quantum computational capability, and it's and if I can, and I'm probably going to get this goofed up, but the problem with a conventional computer is that it. Each time you add a variable, you double the size of the computer, so it's a exponential function. So you get above 32, 33 variables, you can't solve the problem. In principle, a quantum computer is linear with the number of variables and the number of quantum bits. So that it's you could have hundreds of variables. Now, say I want a robot to go into a cave on Mars and look for life, which is something we would want to do, inside caves on Mars, which we know there's quite a few, is a place that you might have extant Martian life. Not likely to be other than bacteria or something like it, but
I'll take what I
you
can.
never know. But it's, you've never been in a Martian cave before. And if you have a robot that you want to send someplace, say if I want a robot to open that door, that's 15, 20 variables, that's pretty straightforward. But if I want a robot to open every door on Google, with hundreds of variables, so I can't solve that problem.
We call them Nooglers.
Yes, that's right. That's
interns.
Well, that's why you have a card, because you don't have to. Even a simple robot can use a card, right? The idea is it's probably, your human brain handles thousands of variables. We'd like to put some of that capability in that robot to go to a place that you wouldn't send humans. And potentially, if you can get a quantum computing device that will operate at the temperatures and compactly enough, that may be the key to us really exploring places like Mars, other places in the solar system. So we're quite excited about the autonomy part of it, and that robots are going to increasingly do more and more. Now, we still think they're going to have a lot of interface with humans. I mean, it's sort of the robot's going to go, hand in claw with the humans when we expand into the solar system. But but this is really where I think the future is.
Have we ignored the gas giants too much?
That's an interesting question. I mean,
We like landing on things.
Yeah,
it seems, and there's not much to land on, but.
No, you can float around in the atmosphere.
Float around, right?
You might have noticed we had an airship for a while at Ames, and it's gone now. It's
I don't think we can send that to
floating in Jupiter.
But
atmospheres are very interesting, and there is some tenuous information that suggests you could have life in Venusian atmosphere, for example, and ideas that you could have interesting chemistry and life and perhaps gas giant atmospheres. Very speculative, but you've got to get in there. And
they're a little toxic.
Well, but there's not very many places that aren't toxic.
Yeah.
Yes, but it's so the idea of using actually balloons and airships in some of these atmospheres is an interesting one, and the chemistry is pretty exciting. So it's that's an area that's a lot of interest in. But there's so many cool places in the solar system to go. My favorite is Titan.
Yeah.
There's lakes on Titan.
Methane lakes, right?
Methane or ethane, depending on your preference.
I think Pete was telling me about basically the concept of basically water ice being so hard, so frozen that it appears to be the land mass of the methane.
Yeah, the rocks on Titan are probably ice.
Yeah.
Water ice, and but it's there's rain that appears. It's ethane or methane rain, and
no
but
smoking.
what?
No smoking.
No, that's no oxygen as far as we know. So maybe it's fine.
Yeah. You can try.
Yeah, but it's although the temperature is a kind of a chilly, but you do have liquids, and there's complicated hydrocarbons. That's one of the more interesting places in the solar system to look for life, and it may be very strange life, and really understand what's the range. But there are organisms on Earth that are methanogenic, that can have various interesting chemistry. There are strange chemistry going on on Titan that could be explained by some methanogenic life. So it's a good place to look, and but it's got lakes and mountains and rain and so on. So kind of a whole ecosystem. And in fact, there was a proposal that NASA, I think, is still considering to actually send a boat to land on one of these lakes. So,
you had a simulation of sorts
right.
of how to do this.
And it's that's pretty cool. Now, being an Air Force guy, that's really a Navy job. But but I think
Mr. Bolden, though.
That's why he's a Marine. It's a Department of the Navy job. But but the number of places to look for life, even in the solar system, we've just begun to look. I mean, Mars is obvious choice. There's clearly water processes going underneath the surface. You actually see with some of the data we have that in spring you see water flowing out from some of the glaciers. I mentioned the Venusian atmosphere. In fact, we don't even know if there's life in the upper Earth's atmosphere. You know, it's very hard to sample. There's a moon of Jupiter, Europa. It's a giant ocean.
That's my favorite. Just because I read too much.
That's right.
Fiction.
Well, there's a ice crust on the. Yeah. You got to get through the ice somehow.
Sure.
But
we have Minnesotans who can.
Well, they were thinking about putting a nuclear thing that melts through.
Sure.
But I kind of like.
It's completely reasonable. I mean,
you have to remember, I'm an Air Force guy again.
Right.
I like the idea of taking an asteroid and running it into it, and blowing a hole in it, and then you can.
That's more organic.
It's
not really a nuclear thing at that point.
Yeah, it's more sure, and then the water's right there, and then
you might get a cool splash.
That's right. Yes. So it's, but I mean, seriously, impacts are something.
We learned a lot from the Jupiter impacts of the Shoemaker-Levy.
Well, and Ames mission a few years ago, the LCROSS, the Lunar Crater Observing and Sensing Satellite. We ran the upper stage of the booster into the lunar poles, and were able to prove that there was large amounts of ice and other volatiles so that if you wanted to potentially have a long-term outpost on the moon, that the resources are there to support it.
As you get further out from the sun, of course, solar starts breaking down. It's not a great source of power. I mean, are we moving back to RTGs? I mean,
well, power obviously in the outer solar system is an issue. There's a couple different approaches to it. One is that you just make things very small and efficient and get them out there quickly. And I think the technology using so-called CubeSats that are sort of a 10 centimeters on a side, or maybe 3 of them together, or 6 of them, is getting to the point that we could actually send a mission, and we think use electric propulsion and get out to the outer solar system fairly quickly. So you got enough power without having to use nuclear. But when you have bigger things, the only feasible power source in the outer solar system is nuclear, and so it's been quite an issue. I mean, the standard power sources are the radioactive decay systems. They use plutonium, and it's in addition to being highly radioactive, it's just toxic on its own right. So it's something that has to be handled very carefully, and there's always concerns about the launch, but we've developed the protocols to do that. But it's, during the Cold War, we made a lot of, other...
Allowances,
well, no, we made a lot of nuclear devices.
Yeah.
So one of the side products of this was a lot of the isotopes of plutonium we could use for this. But, one of the unfortunate things about the end of the Cold War is that from some people's perspective is that we don't have those byproducts anymore. So one of the things facing NASA and the Department of Energy is to restart the ability to produce that. And
well, it's not just those, but I mean, we've had some real problems sourcing medical radioisotopes as well.
And I think this is a broader social and societal challenge, is that nuclear things are scary to people, and that was one of the bad side effects of nuclear weapons. So I think it's clearly something we have to identify. One of the ways to get highly efficient propulsion for humans is to use a nuclear thermal rocket, where you use a reactor to heat a propellant, and you can get 2 or 3 times the thrust efficiency that you get out of a chemical rocket. Or use a nuclear reactor in the outer solar system. We have a lot of electric power to use electric thrusters. So those are challenges, and right now they're pretty expensive. And it's an area that I think eventually we will see nuclear power being key to a lot of activities in the solar system. But fortunately, as long as you're in the inner solar system, the efficiency of a solar system per unit weight is actually more than a nuclear system. So we think out to Mars, we can use solar electric systems. And in fact, NASA's newest initiative is is going to use solar electric power to actually go move around asteroids. And you know, I think it's an incredibly cool thing. And everybody says, well, you know, why aren't we going back to the moon or you know, onto Mars? Well, we are going to Mars, but in the meantime, you know, rearranging the inner solar system is kind of a neat thing.
Yeah.
And you know, and asteroids are threats. So, but solar electric power seems to be sufficient to do a lot of that. So it's kind of a neat area.
You can just tell me briefly what you think of the iodine plasma propulsion systems proposed out of University of Michigan. So I mean, we've talked a bit about it, but
well,
let's talk as if we haven't.
One of the important points is how do you get a CubeSat? Now, I'll get to that in a second. How do you get a CubeSat out? You know, we have a lot of CubeSats, these little things in low Earth orbit, and they're doing pretty neat stuff. But how do you get them out in the solar system? You can use a chemical rocket, but then the chemical rocket is a lot bigger than the. Or you can use electric propulsion, which is very efficient. But the trouble is that it's slow. So there are some ideas, and one of the really cool ones was to use iodine and to heat it with directly use an electric system in a CubeSat that looks like we can get a CubeSat propulsion system that could get us out even to the outer parts of the solar system in short order. There's a group at the University of Michigan, there's Professor Ben Lungmeyer, who's working on that, and we're pretty excited about it because it used to take hundreds of millions or billions to get anywhere in the outside Earth orbit. But if you can have a CubeSat that weighs 10 or 15 kilograms and get it to the outer solar system in a year or so, the CubeSat may cost $1 million or $2 million. That is a revolutionary change that says now the whole solar system is easily and cheaply accessible to scientists. So we're very excited about it. I mean, it's ready for a proof of concept, we think, and it really is the key to interplanetary CubeSats, we think. So,
yeah, and go ahead.
So a long time ago, Ames worked on something called the Ames hard suit, and I thought it was pretty cool. I guess it was killed for various reasons. Will we ever see anything like that in the future?
Well, one of the critical issues now is that where do we go with humans? And Ames is still heavily involved in human factors, and we have some work on suits. Some of those concepts are being continued to be developed by NASA, mostly at the Johnson Space Center, and I believe most of the technology in that one is now being pursued at the Johnson Space Center. However, for the next, probably until the 2030s, most of NASA's work is going to be in deep space, will be with asteroids, maybe the moons of Mars, in which case, the current suits are probably sufficient. But I think these ideas like that, when we do operate on a planetary surface in about 15 years, are going to be critical to it. So the work continues. Our folks are involved in it, but it's not something that is aggressively being pursued.
Most of what you're doing is more interesting than 99% of TV, except when you watch it live on NASA TV, which is as boring as possible. So what do you do to make all the exciting things you're doing more of a spectator sport to really get America's attention?
That's a very good question, and basically, you folks at Google do a lot to help us with that by allowing people to have virtual presence and doing things like Google Hangouts. It really gives folks the opportunity to get to be there and be involved in it, and it's. In fact, this week, we developed something called a space shop, which is a kind of a 3D printer additive, laser manufacturing thing. There's a Google Hangout on Friday, and there's about 1 million young people we expect. They're kind of the Google Hangout campers, and so I think the important point is to use this new technology to let people ride along with us. I mean, things like Google Glass. And so it's just making use of that technology. Of course, there's always a lot of controversy. I learned the hard way to be careful about things like Twitter. Well, I will tell you, as you can tell, I was an Air Force officer, but when we did L-Cross, when we launched it, I was using Twitter pretty regularly, and I had a few thousand followers. You know, it was pretty good for a scientist. And so I went to the final readiness review, the launch readiness review at Kennedy Space Center, and this was the first time I got to sit at the adult table, which, you know, there's like 300 or 400 people in the room, and there's this big wooden table, and the actual people that are primary to say go. And so, you know, they launch vehicles, you know, go, you know, range, go, weather, you know, so on and so forth. And the primary payload was the Goddard Space Flight Center, you know, go. And so I had the secondary, and they said Ames, and I said Ames Research Center is go for the first precision bombing run on the moon. And so I got that reaction, and so I said, well, that's pretty cool. I'll put it on Twitter. That was a big mistake, really big mistake. It got you know, people put 2 and 2 together to get 86, and they said, you know, he used to be an Air Force general and was involved with some other lunar mission that had rumors that it found aliens, and some of the astronauts found aliens, and they said they found aliens, and so that they figured out, aha, this is a secret CIA plot. There's alien base on the moon, and NASA has been enlisted by the CIA to bomb it. And so it was, you know, and I told the scientists when they complained, I said, nobody will pay any attention to that.
Nobody's going to pay attention to that.
Of course, the next call I got was from the administrator, said, several congressmen are quite upset and want to have a hearing about but by the way, L-Cross hit within 100 meters of its aim point. Aliens are gone. Everything's fine.
Awesome. I was going to add the only thing missing is the drama.
Yeah.
Is like, it would have been worth taxpayer dollars, in my opinion, to have sent cameras in advance to be on the ground, watching you hopefully hit the ground. Like, we should double the budget of any mission to include multiple HD live streams to add some drama to it.
I love the idea of doubling our budget, but it's
TV studios on the moon.
That's right. No, but I think it's a good point. I mean,
It's a point.
Why don't you send somebody with Google Glass there to?
Hi. So I'm curious about what you think the role private versus NASA will be in human space exploration. I know, companies like Interplanetary Resources are founded to send probes to go out and collect resources, and it seems like the solar system is opening up to private industry. But do you ever think there'll be a motive for private companies to take over the human exploration part, or if that'll always be NASA's domain?
Well, I'm interested that here at Google you asked me that. There was on your website about 5 years ago, there was an advertisement for some company called Virgil that was recruiting people to go to settle Mars. Now, it turned out it was April 1st, but it had a message from Larry and Sergey, and it had another one from Richard Branson. It was kind of a cool thing. I'm not sure they were joking either, but that's but that really leads to the point.
A couple years off.
Yeah, it might be. But that NASA's job is develop technology to be the explorers and to kind of go out and find out what's there. But I think actually, if we're talking about people eventually living and settling on Mars and other places, that's almost undoubtedly going to be the private sector, and the cost of doing that is beginning to go down. In fact, just yesterday, there was a team meeting at Ames. There's a private endeavor called Inspiration Mars, which is Dennis Tito, who's himself fairly wealthy, has set up this program to send two people to fly by Mars. About every 13, 15 years, there's an alignment of the planets that you can do what's called a free return trajectory. So you can send a capsule and it doesn't need any propulsion. It'll kind of boomerang back to the Earth. And in 2018 is the next one, and so he's trying to do that. NASA is working with them to help them. They have agreements with 3 or 4 of the NASA centers. And I think there's a good chance they'll do that. Now, they're not landing on Mars, but the era when the private sector can begin to do these kind of things is upon us, and they are doing it. Their view is they want to send one male, one female, maybe a husband, wife, to fly by Mars. Now, I'll probably get in trouble with this, but I have to tell a little story my wife said on that says, oh, I can see it now. They're gone 501 days, which is how long it takes. They'll open the capsule, the wife will get out dazed and confused, not remember anything, and the husband will be dead by mysterious circumstances. So,
Martians.
But seriously, I think that we're seeing more and more interest in the private sector. Private sector can go to the space station now. I mean, you can get a ticket. There are people talking about flybys around the moon. So I think a lot of folks in this room will have an opportunity in your lifetime to consider private expeditions, maybe even settlement missions to places like Mars and the lunar poles and maybe other asteroids.
Before we can go out into the solar system or even extrasolar, we still have to get out of this blasted gravity well. And over the years, we've heard a variety of different techniques, some alternative techniques. And I'm just curious to get your opinion and NASA's opinions, if those are any different, on things like the rail gun for inanimate stuff, space tethers for elevators for animate stuff, and the Skylon engine, a fairly recent suggestion, a version of things that have been tried before, but that idea that a space plane can actually take off and land like normal, but get us into orbit. Are any of these viable?
I think a lot of these ideas are viable. A lot of it had to wait for technology to catch up. I personally, in my career, was involved in the DCX Delta Clipper program, which was the idea was to build a single-staged orbit. It was premature, but I now see that SpaceX is actually doing it. Although so far they've just duplicated what we did 20 years ago. I want to add that 20th anniversary of that flight is next month. But it's so things like the Skylon engine is an area that NASA has discussed with there's a British company doing that. Very exciting. So some of these technologies look really interesting. I mean, one that we're working at Ames is microwave thermal rockets that rather than carrying both an oxidizer and a fuel, you just carry a propellant. You beam the energy using microwaves. That heats the propellant, and it gives you, say, 3 times the efficiency of a conventional rocket engine. We have some funding from the Defense Advanced Research Projects Agency. We're going to be testing that here in the next year. We're testing it in the U.S. Well, we've tested it indoors here. Yeah. It doesn't go very far, but fortunately, but we'll be testing that in Southern California and eventually in New Mexico with the Air Force support. So a lot of these things look very promising. I mean, the transportation is hard, and the other side of this is, can we just do conventional rockets more efficiently? And we're seeing the private sector make great progress in that. I mean, and not just one company. I mean, everybody talks about SpaceX, which is a spectacular success, but there are others doing the same thing. So I think at the same time we're trying to make conventional propulsion cheaper. Some of these other things are coming along. So the next 20 years are going to be very exciting in propulsion. And I think you'll see some real breakthroughs.
Hi, so Dr. Worden, you talked about kind of making a space race for speed to get people excited about space. And I was wondering how you balance this kind of competition to get people excited with collaboration, and that there's a lot of redundancies in technology being developed by various private sector and government. And I know, Mr. DiBona, you're very involved with open source, so I was wondering if I could get your take on the balance between collaboration and competition.
Why don't I let Chris answer that first?
So one of the things that I've tried to encourage when I've had the chance with the federal government here in the United States as well as foreign governments is that when they approach contracting and procurement, that they ensure that knowledge is shared. Now, the Defense Department has had some good luck with this, especially around stealth and the rest, basically forcing Northrop and Lockheed to give each other's secrets, as it were. But we seem to have moved away from that in a lot of things, which has been too bad. But I really value your thoughts on that.
Well, NASA and its predecessor agency, the National Advisory Committee on Aeronautics, were really based on free and open exchange of information and publishing. I think an unfortunate trend has been to put a lot of restrictions. I mean, and some of them are legitimate. I mean, there's legitimate concerns about sensitive technologies, but I'm always a great advocate of openness and information. So you want to let people that want to do cool things have access to all the information as much as you can. I mean, I think that I spent much of my career as a Cold Warrior on the U.S. side, and I think the reason the U.S. prevailed in that was because we had an open society with open exchange of information, so that it makes possible the collaboration, and I think internationally that's even more so. On the other hand, people are motivated by competition, so it's when you go see a sports game, nobody's very interested in both sides helping to get the football in the end zone. I mean, that's sort of oh no, you run it in, no, please. The score is 8,000. So I think that we're humans, and there's a competitive spirit. So the key is balancing these two things, and it's capitalism is a pretty good system to do that. As long as it's not unconstrained. And I think that it's NASA's job as a government agency to make sure the information is there for everybody to use, but within our own efforts to kind of make sure that competition doesn't become destructive. I mean, there's always one of the big challenges of NASA is that we compete for especially smaller science missions. There's an announcement of opportunity, and that okay, we want a mission to study astrophysics, and people compete. And NASA centers are parts of that. I mean, I mentioned JPL and Goddard and other places. We compete with them. Sometimes we team with them. And but I think that's good as long as the competition is for a specific item, and it's not sort of like, I'm going to compete to the death with those folks. And it's we have a big challenge now within NASA is what part of our capability do we preserve for competition that might actually be duplicative across centers. So I think there's a balance there, and we do pretty well at it. So but I think in a societal sense, I am really with the idea of open source, open information. Everybody should have access to the same information, and so that they can compete effectively against each other. And a good competitor is one that you want to team with next time. I always find that if we're in a competition at Ames and one of the other centers is on the winning team and I'm on the losing team, I'm the first one to want to go down there and say to the director there, "Can I buy you a drink? Maybe we can work with you next time."
Some help over there. I'd love to hear your thoughts on where NASA's going with heavy boost, large launchers.
I think there's really the question, and this is one we don't have a good answer for, is it better to have if you want to send a human expedition to Mars, I mean, that's going to be something.
Say you want to send a human to Mars.
Right. That's, to land on Mars. That's probably, and come back. That's an important point.
30,000 people volunteering to go one way.
Well, people are going to go one way to Mars to settle at some point, but you need something that's big, probably like this, at least the size of the International Space Station. So is it more cost effective to kind of launch a lot of things and put it together in space, or to have a single big booster? Historically, it's the bigger booster is cheaper. So I mean, if I have a booster that's twice as big, the per kilogram cost is lower than using smaller ones. We don't know if that's always going to stay that way. So what NASA is doing in our internal efforts is we have the Space Launch System. We are aiming at something eventually over 100 tons. In fact, Congress says they wanted 120 metric tons. Our first versions will have less than that. So we're doing that. The private sector is also looking at larger and larger systems. I mean, the SpaceX has the Falcon Heavy, which I think is 60 or 70 tons. They also have something which I think it's called the BFR, the big. I'm told that stands for Big Falcon
Fantastic.
rocket.
Yes.
Big Falcon rocket. That remains to be seen. At the same time, there may be ideas that, if you build a lot of them, small ones will be more efficient. So
There you go.
I don't have the answer, but right now I'd probably bet on the BFR.
Could you walk us through the day of a NASA Ames director? I mean, how do you divide your time? What are you most excited and worried about?
Do you like bacon for breakfast?
Well, I live on Moffett Field, so I get an extra 45 minutes sleep over everybody else, so that's always good. But NASA has 10 centers, and our headquarters is in Washington, D.C., which is where I want it. That's one of the coolest things about Ames, is we're the farthest away from the headquarters.
You can maybe visit the dish.
But that means that they are at work at 5 a.m. my time. And so usually the first hour or two is spent in interactions with headquarters, discussions with one of the leaders of, now, why did you do that? I mean, seriously, we're a big agency. We deal a lot with, I sort of mentioned, we have 550 board members or so on, the members of the House and Senate. So there's a lot of interactions that one does there and answering questions. And I know it's hard for anybody to understand this, but they don't all agree, sometimes, and it's sort of very strange. But it's so I mean, there's a lot of interactions there. Frankly, I have 2,500 people working for me, and they're all very creative. So that means sometimes there are issues that need to be worked with. And I tell people I have 2,500 children, and I'm one of them. So it's trying to figure out how we maximize the opportunities there. But I usually spend a few hours a day just interacting with the really cool stuff that's going on. A lot of tomorrow, for example, all day long is the mission readiness review for LADI, which is our next lunar mission, launched on September 6th. And so that's a really fun day. Now it's fun unless somebody says, "Excuse me, there's a major problem in the propulsion system." Then you kind of, oh my God, what do we do with that? But so we spend a fair bit of that time with that. The other thing is, particularly this time of year, we have 800-900 students at Ames. We have a bunch of folks right here, and I really enjoy interacting with the students. And I think it's so we try to spend a fair bit of time. And I spend a lot of time with discussing people's future. Discussing what's my favorite wine, but
What is your favorite wine?
whatever somebody else is buying. but it's every day is different. But I got to tell you, working for NASA and I hope this is true for everybody, is you really want to get up in the morning and go in and work because it's fun. I mean, we're doing cool stuff. I used to spend a lot of time on airlines. And
Aeronautics is...
Yeah, that's right.
Okay, yeah.
Well, it's one of the advantages, one of the actual positive things about sequestration is that we've really cut travel. So, and we've started to use a lot more virtual presence. For example, this morning, we have this week, the week of the 20th of July is a significant date for NASA, the Apollo landing. And so we always had the Lunar Science Forum, and so we typically have 500, 600, 700 people at Ames. And this year we decided to save money. We were going to do it virtually. So I spent the first hour this morning on the virtual global meetings. First time we've done that, and so that's kind of the wave of the future. Again, you mentioned how do you do things. So every day is different.
Sort of like turning your own in-person manned flight into a robotic mission.
Yeah, exactly.
Where you just send a little box with packets, going back.
It's important though, of course. You have to remember that you're actually like here on, being broadcast, because, there were a couple incidents. We had, NASA employees that were in their kitchens, and the
As long as there's kitchens and other bathrooms.
that's right. Well, you could sometimes hear whoosh in the background, so it's so there are downsides to virtual presence too.
Where do you see Silicon Valley and NASA Ames with the privatization of space?
Well, it's clear to me that privatization of space is happening, as I mentioned earlier, and that Silicon Valley is powering that. I'm really proud that NASA has a center in Silicon Valley, and I think it's really leading a lot of that. It's not the only place, but I can't imagine a more exciting place to be in the world than Silicon Valley for anything. And space is no different than that. I mean, the sort of spirit of entrepreneurship. I mean, you feel it here at Google. You feel it any place in the Valley or in San Francisco. And it's gonna get us to the stars, and it really is that public-private partnership. We're really proud of working with not just Google but our other partners here in Silicon Valley, and this is the future. You never know. What was it? Yogi Berra says something about, think about the future as you never know about it, or something. And it's that where things are going to go, but we're seeing a lot of the private sector space efforts really have their origin here in Silicon Valley. I mean, Elon Musk was a Silicon Valley entrepreneur, and a lot of the other companies, I know at least a dozen space startups here that are doing really well and privatizing things. So I think it's, there'll be a Silicon Valley on Mars someday, and that'll be where they'll build the interstellar starship.
Well, thanks a lot for coming over
Well, thank
and
you.
being here.